Okay, so today we're going to be talking about angle pairs, just different vocabulary associated with it. So at the top of your notes, the first thing you could do, go ahead and highlight where it says adjacent angles. So adjacent angles are going to be two angles that don't overlap. And they share a common side. I think the easiest way to think about it is that they are next to each other. And so when I think about this, angles 1 and 2 are adjacent angles because if this arc right here is angle 1, where angle 1 ends, angle 2 begins. And so they are next to each other. They don't overlap, so they're adjacent to each other. Adjacent means next to each other. That should kind of make sense. Same thing with angles 3 and 4. Angle 3 is right there. Where angle 3 ends, angle 4 begins. So they share that common ray in the middle there, but just the angles are next to each other and they don't overlap. With the second one, vertical angles. Vertical angles are two angles that are across from each other made by the same two lines. So again, if I'm able to, I think you can see that blue line. Maybe I should just highlight it. So they have to be made by the same two lines, which is kind of the tricky part here. So these are two lines that are straight all the way through. I've got my green line and my yellow line. And so the angles that are across from each other, in this case angle 1 and angle 2, are vertical angles. And then angles 3 and angles 4 are vertical angles. They are made by the same two lines, and they are across from each other. The next two, I believe, are familiar to you guys. Complementary angles are two angles that add up to 90 degrees. And actually, they don't have to be adjacent, which is sometimes a little bit of confusion. They could be separate angles, just like angles A and B over here. 47 and 43 degree angles. They add up to give us 90. And so I know that angle A and angle B are are complementary angles, and angles 1 and angle 2 are also complementary angles. And then down here at the bottom, supplementary angles are angles that add up to 180 degrees. So angle 3 and angle 4 are supplementary angles. And then also angle C and angle B. So again, they don't have to be adjacent, but this 137 degree angle and this 43 degree angle, I do 137 plus 43, and I end up with 180, so they would be supplementary angles as well. Up here, angles 1 and 2 are vertical angles, and angles 3 and 4. And then adjacent angles, angles 1 and angle 2. Whoopsie. And then angle 3 and angle 4. Those are all angles that are adjacent up there at the top. Okay? And so just kind of going through this, the question is, are angles BFD and angle CFD adjacent angles? So BFD is this angle right here. BFD, I can highlight it in yellow. And then CFD. CFD is this angle is this angle right here. And if I draw the lines that make it, CFD is this one right here. And so what it's asking is, are they adjacent angles? And our answer should be no, and it is not because they overlap. Where one ends, the other one doesn't begin. They have, like angle CFD is actually inside of angle BFD. So they overlap, which causes them not to be vertical angles. Adjacent angles. The next one down says, are AFB and EFD vertical angles? AFB. And again, you don't have to necessarily highlight your picture just because I'm highlighting a lot. And then EFD. EFD. Oops. And so when I look at this, it kind of looks like it because, because they're across from each other. But the one thing that I do know is that they're not made up of the two lines that are the same. So if I look at, they share this line, that's good, but they don't share the other line. This yellow line right here is right there, and this green line right here is right here. So they don't share the same line, so this is no, they're not vertical angles, not the same line. And then the last one are angles AFE. AFE, this one right here. And BFC. Want to know if those are complementary. And so, again, complementary, just give ourselves a little note. Complementary means a 90-degree angle. And so are they 90 degrees? Well, I can just add them together. I got 62 plus 28 adds up to 90. So it would be, yes, they are 90 degrees. Okay. Again, down here, if I could just name a pair of adjacent angles, any angles that you have that are next to each other, that where one stops, the other one begins. So if I call it angle AFE, again, I just want to figure out the one next to it that keeps on going. So again, if I were to name this angle right here, angle EFD, and then if I did the same thing, so instead of doing this angle, so if I want to find another one that was adjacent to AFE, I could continue around the other way where it stops, do AFB. Go AFE and AFB. There's no overlap, and they're next to each other. Two vertical angles. Let's see. If I were to, when you're naming your own vertical angle, sometimes it's helpful to highlight two lines that go all the way through, because now I can pretty easily see I made a big X. There are my vertical angles, and there are my vertical angles. So when I name them, I can say angle, let's see, that's AFE, and angle CFD. And then another one is the top and the bottom there, angle AFC. That's that top red one right there. And then the other one that's vertical, the bottom part of it would be EFD. Next thing I could do is two supplementary angles. So again, what I could do is two angles that add up to 180 degrees. And kind of like we talked about yesterday in I think it was 1.4. A straight line is going to be 180 degrees. So what I could do is I can see that these guys, I can add them up, and they're going to equal 180, because 118 plus 62 gets me to 180. So AFE and EFD. Another thing that I could do is I could go around here. So I could do EFD and DFC as well. Those are all supplementary angles because they add up to 180 degrees. And the last question here is AFB a right angle? How can you prove it? A couple different ways you can. I think that this was something that you guys may know, but vertical angles are actually equal to each other. And so if you know that this angle right here is 62, Vertical angles are the same, so this has to be 62 as well. If that's not prior knowledge, if you don't know that already, another way you could look at it is if this is 118, and I know that these angles have to be supplementary to each other, I would know that this leftover piece right here has to be 62 because the two angles are supplementary. They make a straight line. They're a straight angle, so they have to be equal to 180. And then I could add these two guys together, 28 and 62, and that gives me 90. So that's a couple different ways of proving it. We don't have to write it down, though. That's all right. A linear pair. So just another vocabulary term. A linear pair are adjacent angles, so they have to be next to each other, where one ends, the other begins, that form a straight angle. And so if they form a straight angle, the important thing for us to remember is that they are supplementary. So with these two problems, it says KPL and JPL are a linear pair, which again means they add up to 180. Let's go ahead and just write 180 right there. That's what linear pair means. And so I know that those two are going to add together to equal 180. So I can go 2x plus 24 plus 4. Oops, I should have started with the letters, my bad. So angle KPL plus angle JPL is going to be equal to 180. From there, I can then substitute in 2x plus 24 plus 4x plus 36 equals 180. From there, I can go ahead and solve, combine my x's together, combine my numbers together. I get 6x plus 60 is equal to 180. I can subtract the 60 to the other side and get 6x is equal to 120. And then divide both sides by 2 and get that x is equal to, I believe, 20, right? Yep. Again, I want to figure out what KPL and JPL are, so I can take that and plug it in for both of my x's. And so I know that angle KPL is going to be equal to 2 times 20 gives me 40. 40 plus 24 gives me 64. And angle JPL, 4 times 20 gives me 80. 80 plus 36 gives me 116. Again, just a real quick double check. 116 plus 64 gives me 180, so I know I'm good. Second problem is the same thing. It says, again, linear pair. That means that they add up to 180 degrees. So I know that angle ADB plus angle BDC is equal to 180. I can substitute my values in. I get 3x plus 14 plus 5x minus 2 is equal to 180. I can combine my like terms and solve from there. It gives me 8x plus 12 is equal to 180. Can subtract the 12 to the other side, get 8x is equal to 168. And then divide it, I think I get 21. Yeah, it gives me 21. So again, plug it in to find out angle ADB and angle BDC. If I grab the 21 and plug it in there, 3 times 21 gives me 63 plus 14. 77 for ADB. Oops. And then plug it in for BDC. 5 times 21, be 105, right? And minus 2, I get 103. Add them together to make sure I'm right, and I get 180, so I know that I'm good. Last thing that we have here, so if we ever have the word angle bisector, angle bisector is the same thing as midpoint, but talking about angles. It divides an angle in half, but the important thing is that the angle bisector makes two congruent angles. So again, on angles, if I want to show that angles are equal to each other, I can put a single arc on both of them. That says that this top angle right here is equal to this bottom angle right there. So this angle is equal to this angle. That's what the arcs mean, and that would mean that AY is an angle bisector. So the important thing with these is draw the picture first, because just like the midpoint problems that we went over in class a couple days ago, it's going to be important that we understand the picture because we can be tricked on this. So don't just assume you know what's going on. This is, so ray AC bisects angle DAB. So I should have a picture that looks just like this. This is my big angle DAB, and this is ray AC that is cutting that angle in half. So I know that this top has to be equal to this bottom. And so what I know is that angle DAC is 58. So this is 58 right there. And so it's asking me what's the measure of angle DAB, the big angle. And so again, if I know that the top is 58, angle bisector, if an angle is being bisected, the top and the bottom have to be the same. So this is 58 as well. And so now the whole thing, angle DAB, would be 58 plus 58, or 58 times 2, which is 116. Whoopsie. So this is angle DAB is equal to 116. Down at the bottom, again, same thing. It's BD's bisecting angle ABC. So if I start with a picture, then I can make sure I know which piece is a part and which piece is a whole. So this is ABC, and this is BD is the ray. Angle ABD, which is the top piece, is 5x. DBC is 3x plus 10. And then again, I know that this top is equal to the bottom. So I know that angle ABD is equal to angle DBC. Each of those are parts that I'm given, so I can just substitute it in. 5x is equal to 3x plus 10. I can subtract the 3x over to the other side. Get 2x is equal to 10. Divide by 2, and I get x is equal to 5. I want to figure out what angle ABC is, so once I have that, I can plug it in. So I know that this top angle right there is 5 times 5, which is 25, which means that the bottom is also 25. So that the whole thing, angle ABC, is equal to 50. And then the last one here from your notes, again, same type of thing. So BD bisects ABC, so I can draw that same picture. So this is A, B, and C, and this is D right there. Again, if BD bisects ABC, I know that the top and the bottom angle are going to be the same. It says that angle DBC, which is the bottom piece, is 3x plus 10. And then angle ABC is 10x minus 32. This is the big thing to make sure we understand, is that this big angle, so angle ABC is the whole thing. Angle DBC is just the bottom piece. So again, don't just think angle bisector, make the two things equal to each other regardless and solve. What I got to know is that the bottom and the top are the same. So this top is going to be 3x plus 10 as well. I'm going to add those two together, and it's going to equal the whole thing, 10x minus 32. So I can go angle ABD is equal to angle DBC. That doesn't help us because, again, it would just be 3x plus 10 is equal to 3x plus 10. So I got to go to angle ABD plus angle DBC is equal to angle ABC. The parts add up to equal the whole thing. That's segment addition postulate. Once I'm there, I can go 3x plus 10 plus 3x plus 10 is equal to 10x minus 32. Solve from there, and I get 6x plus 20 is equal to 10x minus 32. I can subtract the 6x over here. Get 20 is equal to 4x minus 32. Add the 30, well, that's a bad 2. There we go. Add the 32. It would give me 52 over here is equal to 4x. I believe that would be, what, 13? Oops. Yeah, 13. So x is equal to 13. That'd be my answer there. And again, if I wanted to find out what angle ABC is, I can grab it and throw it in right there. 10 times 32, or sorry, 10 times 13 minus 32 gives me 98. So angle ABC is equal to 98. Sorry, guys, that was kind of a long lesson, but they usually won't be this long.